this test before fall break than after. Just saying.
That's what I'm saying. So there's like ringleader.
All right, lock it in. Bring it back. So we're going to be doing operations on functions. You guys have done this before. We did this in Algebra 2. We're going through it again, okay? So it's going to use some of our weird function, and we're going to start mashing things together. But you have done these before. Because what we're doing here, when we say f plus g of x, is we are going to be taking function f of x and adding function g. Okay? When it says f minus g of x, we're going to take f of x and subtract g of x. Right? So when it says fg of x, what are we going to do with the two functions? Multiply them. F of x times what? They're all the same. They match up. I was gonna say you're crossing somewhere. They should just be doing the same operation between our function rules. And then the last one is we're gonna take f of x. That f looks weird. We're gonna rewrite that because that was so weird. F of x, and we're gonna divide it by g of x. So we are also going to have to think about domain and range of these. On these guys here, all three of the top ones, the new domain must be within the domain of both. So if one of these functions has a restricted domain, like the square roots had to be positive, then our composition, when they're together, has to be within that limited domain. On the bottom one, it's going to have the extra rule where, yes, it has to be within the domain of both, but also g of x cannot equal 0. So it has to be within the domain of both, but when you divide, you still can't divide by 0. Okay, so we're going to be looking at domains and ranges of these, or not ranges, domains of these compositions here. Or these operations. Okay? I see pen's mostly stopped. Anybody need more time?
Yes.
Okay. That's why I asked. All right, because we're going to be doing this. We're going to practice this, working on them together. Because we're going to do it. I've got two function rules up here, and I know it's kind of hidden behind the little thingy here. X squared plus 2. F of x is x squared plus 2, and g of x is 2x squared plus 1. We are going to do all four of these operations and find the domain. So it's a lot of stuff. So I'm going to do f of x in purple. And I'm going to do g of x in this light blue so we can see the difference. It's x squared plus 2. Sorry. It's really clear on my iPad, but then it got on the screen and it's right behind the weird buttons. F of x equals x squared plus 2. That's what this says. It's just behind the program. Oh, yes, plus 1, sorry. It's right on the edge. G of x. I was trying to maximize our screen space for workspace. Plus 1. There we go. Okay. So for f plus g of x, this is where we're going to take f of x and add g of x. F of x is x squared plus 2. We're going to add 2x squared plus 1. So when we simplify this, what do we get? Yeah. So f plus g of x equals 3x squared plus 3. What is the domain for f of x? What's the domain for this one? Say it louder though. What's the domain here? What x's work? All of them. From negative infinity to positive infinity, right? How about for g of x? What's our domain here for 2x squared plus 1? All real numbers. Again, from negative infinity to positive infinity. So what's the domain going to be of f plus g of x? All real numbers. We can also kind of see that in the problem. It's an x squared. It's a parabola. Parabolas have the domain of all real numbers. So we're going to do the same process going down all these, and we're going to find our domain as well while we do this. So our next one is that we're going to take f of x and subtract g of x. So f minus g of x is our x squared plus 2 minus 2x squared plus 1. So I'm subtracting the whole function. Which means our difference here is going to be what? Because we have x squared minus 2x squared minus x squared. And then we have 2 minus 1 plus 1. So we're subtracting the whole function rule. So if you need to write it out as another step, that's totally fine. Distribute the minus sign. Okay, we see where that came from? No? I heard a no. Let me bring it in. I'm just going to pop in real quick. There we go. Woo. There we go. Just so we can see it a little clearer. So we're subtracting our two functions. I distribute the minus sign through. So it becomes x squared minus 2x squared and 2 minus 1. That's where we're getting all these pieces. So if you need to write out that extra step, do so. But it's going to be one of those things that we're going to fly through these kind of fast. What is our domain for f minus g of x? All real numbers again. From negative infinity to positive infinity. We're putting it in interval notation. Yes, dear.
How do you know if it's negative infinity to infinity?
So we can find our domain here, and we can do that by like kind of looking at our rule and seeing what needs to happen. Like on square roots, we know we're not going to have a negative under the radical, right? If we have a fraction, we're not going to have a 0 in the denominator. With this, it's an x squared, so I can take and square whatever number in the world. So it's negative infinity to positive infinity. And it's the same thing here. It's an x squared. And we'll see what it looks like when it's a little different on the next one. But these are all parabolas, so they're all real numbers. All right, so then we're going to do our multiplication. I'm going to lock this out onto the big screen again so I can zoom in. So we're going to take f of x times g of x. So I'm going to put everybody in parentheses when I write them down. X squared plus 2 times 2x squared plus 1. Box it, distribute it, whatever you need to do. What is the product of f and g? So 2x to the fourth plus x squared plus 4x squared plus 2. Can we simplify that? Yes. 2x to the fourth plus 5x squared plus 2. You can do this with distribution. You can box it. You can do whatever you need to do to multiply it out. So we combined like terms with the x squareds. I had 1x squared and 4x squareds, but from here, that's as simplified as we can go. This is what the product of fg of x equals. What's our domain here? All real numbers again. It's from negative infinity to positive infinity. There's nothing that stops me from putting a million in place of the x, or negative a million, or 0, or 2.897643. Nothing that stops us from putting any particular number in place of the x's here. And then our last one on this page, we're going to do the quotient. You're going to divide them. So f over g of x, we're going to take f of x over g of x. X squared plus 2 over 2x squared plus 1. I'm going to change our view real quick so we can actually see what's going on here. Can I cancel out the x squareds? No. If there is adding in my fraction, you can't cancel things out. We can only cancel out when there's multiplication. So we would have to factor stuff to be able to start canceling things out. That's our answer. We're not simplifying this in any way, shape, or form. All we have to do is find our domain. So the domain of the numerator is the domain of what it was. So our domain here, we're going to start with this, negative infinity to positive infinity. But then we also have to find out where that denominator equals 0, because I can't have a denominator of 0. So when does 2x squared plus 1 equal 0? Huh? So x squared, I heard a couple of us get there, gets negative 1/2. What number squared gives us negative 1/2? What number squared gives us a negative? No number. So there is no place where our denominator equals 0. So our domain is this. Okay? Our denominator never equals 0. So we're good to rock and roll. Our domain is all real numbers. That's an R. There we go. Okay, so these are weird. These are weird. And that's okay. Because we're going to do it again. Or we're going to do parts of it again. We're not going to do all 4 on the same set. Again. Yet. Okay. So we're going to do another product. So we're going to do the f times g. F of x is square root of x plus 5. G of x is square root of x plus 5. So when we do f of x times g of x, which is what we're asked for, is f of x times g of x, that's what this says. We're going to take the square root of x plus 5 times the square root of x plus 5. Right? What's going to happen when I multiply the square root of x plus 5 times the square root of x plus 5? Because, yeah, I could rewrite this as the square root of x plus 5 squared, right? So what's left over? Just the x plus 5. Because my square root and my square cancel out. Then we're going to look at our domain. Yes, I will slow down. Those of you that have caught up writing, look at our domains for f and g. See if you can figure out what our domain is. See if you can figure out the domain for f and for g. Ooh, hot water. So what is the domain going to be for f of x? What do my x's have to be in order for this to work and not get imaginary numbers? What's under the radical has to be greater than 0. So what does x need to be bigger than? Bigger than -5, right? So we can take anything from -5 to infinity, right? Because I could do square root of 0. 0 is fine. We can include the 0. How about for g of x? What's our domain? Same. From -5 to infinity. So what is the domain of this from -5 to infinity? Even though this looks like a linear function. Like we could graph this the whole way across. Since it's a composition or since it's a product, it has to be the domain of the pieces that built it. So this one's domain is going to be from -5 to infinity. That's a comma. Even though we could, if we were just given x plus 5, I could graph that at -7. Like, totally fine. We could do that. But since it's made up as a product of other functions, it is limited in its domain to what the pieces that built it were made of. So the product of f times g of x is x plus 5 on the domain -5 to infinity. Okay, so again, the domain part is probably the weirdest part of this. The composition stuff you guys have done. The products you've done. In Algebra 2, you did that. It's the domain that gets a little weird. Okay, how are we feeling on this one? Okay, ready? All right, so we're going to do an addition and a division for these two rational functions. Meaning they're fractiony. So again, I'm going to do f of x. We've got 2x over x minus 4. And g of x is x over x plus 5. And we're going to start with f plus g of x. So f plus g of x is our first one. That's when we do our f of x plus g of x. So that's going to be our 2x over x plus, or x minus 4, excuse me, plus x over x plus 5. Unfortunately, we can't leave it like that. We gotta simplify it. What do we need to do to add fractions together? What do they need to have? Common denominator. What do I need to multiply this one by to get to our common denominator? By x plus 5 over x plus 5. And the purple one, what do I need to multiply that one by? X minus 4 over x minus 4 to get to that common denominator. We're multiplying it by a funky 1. So what we're going to have here is our numerator is going to be 2x squared plus 10x plus x squared minus 4x over x minus 4x plus 5. And then we're going to simplify that because that looks super gross. What's our numerator going to be? 3x squared plus 6x. And our denominator, we're going to leave it in our factored form. X minus 4, x plus 5. If you want to switch this to factored form, you can. But we can kind of see that nothing's going to cancel out, so I'm also okay with us not factoring it out. Because we're going to wind up with 3x and x plus 2. So then let's look at our domain for this one. So first thing we got to start with is what's our domain for f of x? And I'm going to write it in not interval notation because it's going to be way long. What is the one thing x cannot equal? X can't equal 4. The denominator cannot be 0. So it's when x minus 4 equals 0. My denominator can't be 0. X could be 0. I can have 0 over negative 4. Totally fine. But my denominator cannot be 0. So x cannot equal 4. How about on this one? X cannot equal negative 5. So for our composition down here, when we added them together, what is going to be my rule on the domain? X cannot equal what? X cannot equal 4 or negative 5. So it's both. And you can see that down here because both of those are in the denominator. We can't divide by 0. Okay? So then let's look at the division part of this. I'm going to extend it down, which means I'm going to have to change my screen. So if we needed to put it into interval notation, it would be from negative infinity to negative 5, unioned with negative 5 to 4, unioned with 4 to infinity. It's a lot. This is the interval way to say everything but 4 and negative 5. Unless it specifically tells you interval notation, yes. Sometimes it will specifically say interval notation, in which case we got to go long way. So let's look at our division, our quotient. F over g of x. This one's actually shorter. It looks really scary when we write it out, though, because we're going to do f of x over g of x. right? Oh, I just switched my colors. Let me switch those back. F of x over g of x. There we go. Just trying to keep my color coding good for you guys. So I'm going to write this over here, and then we'll work down below. Just I want to be able to see stuff. So on the top, we're going to have our 2x over x minus 4 divided by x over x plus 5. Ew, right? I'm going to give us a barrier here because I don't like the way that it's all blending together. There we go. Barrier. Visual separation. When we are dividing fractions, and we have fractions on top of fractions, what's a way that we can fix that and have it not look that gross? Multiply by the reciprocal. So we're going to have f over g of x is 2x over x minus 4 times x plus 5 over x. This is when we multiply with the reciprocal. That's a C, reciprocal. Okay, so what are we going to get here when we start to simplify this? We're multiplying these two pieces together. 2x squared plus 10x and x squared minus 4x. Huh? You can. We can see if anything will cancel out. I don't think it will. Because we're going to have, I was like, it never hurts. You can always try it. 2x. We're going to wind up exactly where we were. It's got to be 2x times x plus 5 and x times x minus 4. So you can, but it puts you exactly where we were over here.
It's 2x over x with the multiplication. Can you cancel out
We could cancel out an x.
I mean, I don't know if that's helpful, but...
Again, I don't know. Again, also, I don't know if that would be helpful. Really? I am fine with this being our answer. We're not going to graph these things. So canceling out the x isn't really going to change much for us. And in fact, the one thing it would do would make it really hard to spot what's different in our domain. Because what is different in our domain with this one? What else can't the denominator equal? 0. Just straight up 0. So x can't be, it can't be 4. X cannot be 0. What else can't x be? -5. That restriction from our piece that we used to build this is still a part of that. Okay, so our products, our sums, differences, products, and quotients have the same domain rules that the original functions had, plus whatever happens when we change it. So this one has 3 things that x can't be. Came from the original g of x, where it could not have it under there. But since we're playing with all kinds of things, it makes new rules too. Okay? Give me 1 second, because I'm going to pick one of the ones I have left for us to do. Let's do this one. Okay, this will be our last one for today. Because they have things like this in the homework. F minus g of 2. F times g of 2. So what we're going to do is we are going to do the same operations we just did. And we're going to find f minus g of x and then plug in 2. I mean, you could do it the other way around and do f of 2 minus g of 2. I'm going to start with doing my f of g, or f of x minus g of x. So we're going to have our minus x squared minus 2x minus 1. And we're going to simplify that. When we simplify that, what are we going to get? G of x is 2x minus 1. Sorry. Changing it. Subtracting. We're on subtracting now. So minus x squared minus 2x plus 1. So that's f minus g of x. If we want f minus g of 2, what we're going to do is we are going to substitute in this 2 in place of the x. The opposite of 2 squared minus 2 times 2 plus 1. Ooh, sorry, that's real small. You guys okay if I zoom that in? I was just way at the bottom, and I didn't want it to be quite that small. There. Because if we simplify this, we have the opposite of 2 squared gives us 4 minus 2 times 2 plus 1. So what's our answer here? Negative 8 plus 1, so we get negative 7. So we're going to do the composition and then plug in the number. Same thing for the f times g. It's the same thing. We're going to do f of x times g of x and then substitute in the 2. And we still have 2 minutes, so we have time to do that. So we're going to take our minus x squared times our 2x minus 1. What are we going to get when we multiply these? Negative 2x what? Cubed. Minus, I heard you say minus. Plus x squared. We did this multiplication. And we are evaluating it at 2 again. So we have negative 2 times 2 cubed plus 2 squared. Bringing you back in, sorry. So we have negative 2 times, what is 2 cubed? 8 plus 4. So we have negative 16 plus 4, and our answer here is negative 12. So there are a couple on the homework that are asking you to evaluate and then substitute in a number. So I wanted you to see that before we get on it. And tomorrow we're going to do like the true composition of functions, f of x, g of x, and f of g of x of 8 tomorrow. And then that'll be it for the rest of the for unit 2. I will get you guys your chapter reviews probably tomorrow. The quiz is, the unit exam is Friday. Friday is the day. Boop. This is the last homework of the chapter. It's fairly short. But the unit test is Friday. Friday's the test is Friday. I will get the reviews to you probably tomorrow. I gotta finish typing it up.